All right, let's go ahead and get started. Today's class is an Introduction to InventorCAM Part 2, Menus and File Management. Should only take around 30, 35 minutes, something like that, but let's go ahead and jump in. We're going to go ahead and start a new project on this part. So we're going to come up to the ribbon and say New Milling. Now this dialog here is where all your project files are going to be placed, what it's going to be called, what mode it's in, whether inch or metric. You also have an option of doing it in assembly mode or into part mode. Now, I always recommend assembly mode simply because you have the ability to work on more than one part at a time, or full assembly, or you can bring in vise, table, parallels, your fixtures. But if you have an Inventor Lite version, you can go ahead and do it in part mode. Starting up here at the user model file directory, I can't get in there right now, but that is actually the first directory that you chose in the CAM settings a couple of weeks ago. This is just a default location. If you don't check this, then you can put it wherever you like. I'm sorry, let's reverse that. If you deselect it, it's going to go to the directory that you set inside the CAM settings. If you use model file directory, it's going to place the CAM project files in the same folder as where your IPT file is. Now by default, we just take the name of the IPT file and we give it the name of the project, but you can rename that now or you can rename that later. So I'm going to leave it as is. I am going to be working in assembly mode and I am defaulted to inch. I'm just going to go ahead and select OK. So right now, because of the mode I'm in, it's making a perfect copy of the original part, and it's putting the original part away for safekeeping. So now the part you're looking at right now, it's got two different names. It can be called, it's the design model, but it's also your target. Okay, it's what you're shooting for. This should be the post that you defaulted, and I actually have gone through and I've messed with my settings. So my actual default post that I like to use is one of these down here somewhere. There we are. So your post should already be defaulted, but you can go ahead and pick that right now if you haven't chosen that yet. So really the first thing you have to do is define a coordinate system. So I'm going to go ahead and define a coordinate system, and there's a lot of different ways to do that. Selecting a face is probably the easiest. In fact, let's just start at this by 3 points. 3 points associative works really well if you have a configuration or an iPart version that's going to be changing with the parts getting bigger or smaller, and you want, let's say there's a datum point over here on the part and it's referenced to a hole over here. Well, you can put a datum on here. You can reference it by 3 points, so if the part changes, that datum still stays the same even though the hole, the distance is changing. So, or vice versa, you can actually have the associative point move closer to the hole but still be on that wall. Can be very powerful. Most people don't need that. It's really for special cases. Normal to current view is really used for the best place to use it, in my opinion, is probably 5-axis, when you can rotate the port or what you're trying to cut right up to the best possible view, and then you can take a snapshot like this. Let's say, for whatever reason, that was the best possible view. I wanted to get into it from this way, looking straight down on it. I could simply go to normal to current view, capture the current view, and you notice that the Z-axis or spindle axis, I'm looking straight down it right now. So if I rotate this part around, you can see that I've created a view just as I'm looking at the part. Selecting coordinate system simply means you can select the coordinate system that's already been created or set up inside Inventor. So you can just grab one of those. All right, defining it, you can actually pick the origin, then the X direction, then the Y direction. So let's say I want that as my origin. My X direction is this way. My Y direction is, I don't know, we'll call it that way, even though it's crazy. There it is. Very straightforward, but honestly, select face is the easiest. Remember, any face that you select, it's going to align the Z-axis perpendicular to that face. So if we choose the top face, you can see that aligned it directly up there. Now in a case like this, you might want to do that, but maybe you want it to be along this wall or something. I don't know. You can always change the X direction by simply picking X direction. And you can flip that around too. You can flip it right here if you go around Z. So you have a lot of control. I think selecting the face is the easiest. In my opinion, I would just simply select the top face, or any face for that matter. It doesn't matter. Let me do that again here. Pick face. Oops, even that face works for me. It's still going to set it at the top of the block because I said corner of model box. And if you do top of corner or top center, of course, it doesn't matter which one you pick, it finds the center of the block. So go ahead and do that. We'll go ahead and keep that in there, and we're going to hit finish. So that's our coordinate systems. Now, at this screen, there's not a lot to do. In fact, there's nothing to do, really. The tool start level should be set up and out of the way. This shouldn't be turned on in your post, but if it is, you can turn that off, or we can turn that off. But what I like to do is I like to just grab a number that's above, well above the rapid plane, because this is the rapid plane, this is the top of your part, and that's the lower bottom of your part there. This doesn't matter. Don't worry about that. Just set it to 10 or out of the way. But this one could potentially be turned on. So what I would suggest is, if you want to know if it's turned on or not, put in a weird number here, and then when you post out your first code, you'll know if it's in there or not. Okay? So, but we're not going to worry about that right now, so just leave it up and out of the way. That should already be set for you because we set this in the settings 2 weeks ago. So at this screen, you should really only have to look at 3 numbers, just kind of a double check. Here's your rapid plane, and it's always going to be 1 inch above wherever your upper plane is. Okay, your upper level. If you've chosen your upper level at the bottom here, so that's going to be a -1, this is going to be a 0 because that's going to be 0. That's going to be 1 inch always above wherever you put your coordinate system. Okay, and this. Let me rephrase that here. This is always going to be 1 inch above the top of your part regardless. So even if you put your coordinate system down at the bottom, upper level would be 1 inch, and your clearance level would be 2 inches, and this would be 0. Okay, or actually whatever the length of the part is. Sorry, it's the thickness is 1.575. So that would simply be 1.575. This would be 2.575, and this would be 0. So just know that this value, whatever you set your rapid level, your clearance level in settings, is always going to be that value, which in this case is 1 inch above the top of your part, regardless of where you put your coordinate system. So look at them, make sure they look okay, simply click through it. Mac 1 position 1 simply means machine position 1, or G54, FADAL, E1, whatever your work coordinate system offset number is supposed to be. Now, by default, it's 54, but you can rename it to whatever you want. So if you have multiple coordinate systems in here, you can rename it by default to be 54, 55, 56, so on and so forth. But you can rename them all to 54. So in a 3X environment, that's generally what people do, unless they're working with multiple vices. So we're going to go ahead and accept that. That was our coordinate systems. Stock and target technically don't need to be defined for a 2-axis part. However, there's 8 different simulation modes, and most of those require that you have stock and target defined. Now, you may or may not have already set this up in your settings like we did 2 weeks ago. I generally like to set mine each time, but you can set these to where they're already set for you, especially the target. Now, that one you might already have set, so you might have a check in there already. That simply means that whatever's on the screen when you started a CAM project, it shows it as your target. So, and that's fine. That's just one less click. But let's go into the stock first, and we'll talk about that. There's a lot of different ways to define stock. Box option, and we're using relative to the model right now. You select your part, it builds a box around your model according to these values and relative to the model. That simply means that, well, I'm an extra 100 thousandths bigger in X positive, X minus, so on and so forth. If I change these values, you will see it update on the screen. Okay, so that's relative to the model. If you wanted to build an exact size of some sort, you could just simply do absolute coordinates, And now you have a 2 by 2 block. And of course you can make that bigger. You can go 5 by -5. Whoops. So you can build in the exact size that you're looking for. I don't know what this is. It should be. Try it again. Let's go 10. Yeah, it's close, but so yeah. So you can build in the exact size of model that you're working with using absolute coordinates. Now that's the box option. Same thing happens with cylinder, except obviously it's a cylinder. And you can change the values, either do it in relative to model mode, or you can do in absolute coordinates. You can extrude a boundary. This is kind of cool. You simply chain your part, and let's loop that around, and we'll show it. Notice how it automatically extrudes it up to the length or the width or height of the part. Okay, that's extruded boundary. You can bring in an STL, so you can browse to your STL files if you'd like. Let's open that up. I know this isn't the one, but we'll show it. So that's just an STL that I had. Or my favorite is 3D model. Now 3D model requires that you have a model in here, or you can import one. So if you haven't imported one yet, then just skip this until you've had a chance to import it. You do not have to define stock in order to continue. Really all you have to define is your coordinate system. Then you could simply save and exit. Then you would go over to your assembly view and simply import a model. Then you can simply come back in, double click on stock or double click up here, get right back into stock and pick what you need. But for today, I'm just going to use the box option. Now, if you do choose the box or the cylinder option, you do have one other option down here, add box to CAD model. This is if you want to take this live representation of what the stock is, because right now it'll use this. There's your stock. But if you want to be able to click off of these lines here, then you're going to want to add box to the CAD model. So I'm going to go ahead and do that. It's going to create in wireframe there for me so that I can click off of it. Now, one other thing down here, the facet tolerance. This has no bearing on your G-code. This simply has to do with the display tolerance only. Okay, how nice the part looks when you go into Solid Verify. The tighter you get this, obviously, the nicer it looks, but the slower your computer's going to run unless you have a really fast one. So I generally set my stuff at a 0.5 thousandths because I got a pretty fast computer now. I can even set that lower, but 0.5 thousandths is more than good enough, I think. So I'm just going to go ahead and hit finish. All right, there's my stock and my target. Target is simply the model you're trying to make, and again, yours might already be chosen, but if you came in there, it would look like this. All you do is deselect it, select it, or you can deselect it here. Doesn't matter. It's all the same. Again, there's your facet tolerance for the target. Again, no bearing on your G-codes, just simply display tolerances. And of course, you can show it as well. There we go. And let's go ahead, CAD selection. You can go into CAD selection, so you can pick surfaces and individual surfaces, where you can do that here too. But you can actually select features inside the tree if you'd like. But we're not going to do that. We're going to go ahead and hit finish. Now, stock and target have been defined. So is our coordinate system, and our machine is already there. We're not going to go through our machining today because that's not what we're about. We'll do that on an iMachining lesson. So that's pretty much all you have to do. Actually, let's go over one thing real quick. If you were to rename your coordinate systems and you wanted them to be whatever the names were, there's this work offset method. Simply put that to 1. That means that whatever they're named, that's what they'll output in the G-code. So other than that, let's go ahead and hit save and exit. Now we finalize the project. This is our InventorCAM tree. Everything that we just went through is located right there in your CAM part definition. You can double click or you can right click and you can get right back there. And we're going to go through this menu here. So CAM part definition, if I go there, you're back into here. Right click again, CAM part properties. This will give you information about your part. You know, what's the model name? Where's it at? You know, if you need to get there, just copy in the directory, or actually the directory's right here. You know, when it was created, the size of it, whether it's compressed or uncompressed, inches, and again, you can highlight that stuff and use it. So, change model reference. Let's say you get a revision. This one's called bracket, okay, right here. And then you get a part that's bracket Rev A. Well, and you've already put a bunch of toolpath on it. Well, you can simply come up here and browse to the new file. It will close this file. It will open up the new file, but it'll keep all your toolpath, and it should automatically update the toolpath according to the new file, provided it's the same one, just revisions. The other way to use that, which is possible, is let's say that you're going to use most of the toolpath here on a different part, even though it's totally different. Well, you could do a save as and simply save it as a new project name, and then come up to change model reference and change it to the new model. Then it'll close this one, open up the new model, and bring in all your old toolpath that you can now apply that toolpath to the new part. So it's another way of using it. Open from PDM, this is just a way to, you know, your files open, and there's another save to PDM down here as well. This is for Vault. If you happen to have to check in your files or check out your files, this is opening from PDM or saving to PDM. Close is the proper way to close your file. If especially you're working with an assembly, you're gonna and in compressed mode, you're gonna want to do the close. Okay, I close if you're not in compressed mode. I close it from here all the time, but that is technically the proper way to close your file. Save as, that is the proper way to rename your project. You do not want to rename your project outside there. And once we get this finalized, actually, before we go any further, let's do that. Let's take a look at what's got created when we finalized our CAM project. So mine was inside here, and we did bracket. Okay, so here's the original file we started with today. So that was the one that we started the CAM project on. When I finalized the project and I got to this window here, this is what got created, a PRT file and a folder of the same name. Also, you know, obviously it's the same name as the IPT because I did not change the project name. So the bracket PRT, you can notice it's only 11.6 kilobytes. It's very small. It's nothing more than a pointer file and a manager file. So it basically points to and manages everything inside the folder. Now what you're going to see in here is the assembly we created, an empty CAM part, and the design model. The design model is the perfect copy of the bracket. Okay, they are exactly the same thing. So if anything changes in here, it will automatically update the design model. Okay, now let's take a look at those files, and we'll come back here in a second, inside Inventor. You don't see them here, but if you go up to your InventorCAM Manager and go to Model, you can look at it in Assembly View, or you can look at a Modeling View. If you're going to edit stuff, you need to be in Modeling View. Otherwise, you can do Assembly View. So here's the assembly that we talked about. Here's the empty CAM model, although it does have stock in there because I created a box. Remember that. We'll come back and talk about that. And there's the design model, the perfect copy of the original part. Now, why do we create a CAM model? Well, this is how we handle revisions. Let's say that you've CAM'd your model. Okay, you've CAM'd your project. You're all done, and you get a revision. So they take this one, and now they call it something different, or it's exactly the same name. They drop it right back into this folder, but it's different than this one right here. What happens as soon as you open up the project, it's going to let you know something's changed, and it's going to automatically update everything in here. But it will not update everything in here or at the assembly level. So that means if you've built in boundary curves, surfaces, solids, whatever, you're going to want to build them inside the CAM model, or at the assembly level. Don't build them inside the design model because you'll lose those changes. So that's how we handle revisions, and generally that's where we put our stock as well. Now, if your stock isn't in here, if you're doing 3D model, then you could simply go to assembly and bring in a 3D stock if you'd like, place it, made it up where you want it, and now you're going to have a third element in here, and that would be your stock. You can have multiples in here because we're in this assembly, so you can bring in as many things as you want, like your vise, your table, your parallels, that kind of thing. So going back to here, so this is the original file, but this file here cannot update and will not update anything in here. Only the other way around. Only this one can affect that one. That's what follows the ISO 9000 rules. Now there's some files in here. Block file, that's something Inventor does. M.tab, that's a local tool library. Stock, GM, and target GM were created when I hit show model or show stock. Those are what got created. Now, as the project grows, so are the files going to be in here. They're going to get more and more files in here. All right, going back to here, let's go ahead and go back to all right. So close, just real quick, back here. You do not want to rename this or rename that. Don't do it. Don't rename it from here. I stress that. Only rename it from here. Save as. Okay. Save updated stock DSDL. Well, let's say you did a lathe part. You don't have a mill turn, but you have a turning machine and you have a mill machine. Well, you could turn your parts, do your projects on the lathe. Then you could save updated stock to STL and then open up a milling project and bring in, remember in our stock, we can bring in an STL model. Okay, so you could bring in that STL model from your lathe work, and then you'd already have your stock as it looks right now. I don't particularly like STLs because there's nothing on STLs that you can physically click on. So they are as they are. There's not much you can do with them. But that does work. Export CAM part data to NC simulation. It's pretty self-explanatory. It exports the CAM part data for simulation needs, for NC simulation. That means actual G code, okay? But you have to have a third-party G code editor in order to do that. Let's start with documentation DPP. This is old legacy setup sheets, basically. If you haven't, if you're not currently using them, which I doubt, this is really, we've kept this around for some of the old timers that have been with the product a long time, and they started with these and they want them and they want to keep them. If you want setup sheets, you're going to want to go into documentation tool sheets. Capture image, simply you can zoom up, in some particular area of your part, and you can simply say capture image. Then it automatically captures that image, and when you go to build a tool sheet, it will embed them into one of these. Now we could generate one right now, but we don't really have any toolpath yet. We haven't done anything. So you can generate a docx, an HTML, rich text format, or a version of Excel spreadsheet. I like the Excel spreadsheets. So they can be fancy, but they are open source and text editable. So you have the ability to change those. Put in your own logo, main part. You can put in all kinds of notes here if you'd like. All right, DNC. If you're not currently using any kind of a DNC, this is not real important to you, but if you do send your G code to the machine via DNC like RS-232, then you can go ahead and path this. There's a place in settings up here where you can path your DNC to a program that you use for DNC, and I don't know where that's at. Where am I? That's the editor. Maybe it's a miscellaneous. There it is. Path for DNC tool. So if you have a third-party DNC tool, mine actually is inside my editor. So as soon as I post G code, I go to a separate editor, and it has a DNC tool. So basically all you're going to do is path to an executable in order to use that option right here. Then when you click on it, it brings up your DNC tool and you can export your data to the machine. But of course it has to be hooked up. Synchronizing. Because of the mode that I work in, if I do get a revision and anything changes, whether the target will probably be updated and any one of the toolpath that gets affected by that update are going to have that familiar yellow lightning bolt over the top of whatever's been affected. So if it's over the top of the target, you can right-click on the target and say synchronize, or like I did, you can right-click at the top here and synchronize everything in here. Then you can come down to your operations or pick directly here, synchronize. You can't see it all, but because we don't have toolpath yet, you can synchronize and calculate all your toolpaths, or you can click on individual toolpaths, right-click, and say synchronize. Now, that's because I'm in semi-automatic mode. If you're in fully automatic mode, as soon as you open up the project, it'll automatically be updated, so you won't need this. New user, iMachining Info, iMachining Successes, iMachining Professor, and InventorCAM Professor are all links to the website to view videos, hundreds of different videos for whatever you're looking to do. So you can go in here, welcome to Inventor, you can go into Professor, go into iMachining, training stage 1s. These are different trainings than the ones that I'm doing right now. So you can, and if you're not registered, it's free. Just register for account. Then you can get in here and watch hundreds of videos. And you can do that for, all these, as I said. So I'm InventorCAM Professor. That should take you right to InventorCAM Professor, Jump Starts, and there you are. So you can just watch, they're very helpful. Get you really going. All right, send to, very important. Let's say you've got a file that you need to send to your buddy at work, or you have a problem with it and you need to send it to tech support. Well, simply go to send to, mail. It's going to automatically zip up your entire project, your post. It might even zip up, if you want to. If you have machine simulation, it'll zip up that too as well. But this will take it right for the mail. You can zip it up and just stick it in a folder, or you can zip it up, put it in a folder with including the machine simulation files. The machine simulation files are the files of what your machine looks like. It's your SDL files, basically. So if you don't have machine simulation, you don't have to worry about it. CAM cleanup part, very important. When you're done camming your entire project, you're going to have elements that you're probably not using, drill points, maybe some extra stock, or some profiles or boundaries or something that you thought you were going to use, you created them, but you're not going to use them. Well, you can just come in here and do select all, clear it all. It even gets rid of unused tools or fixtures. It clears out everything that you're not using in the project. So if you know your project's good and you just want to clean it up, this is a great way to reduce the file size. I do that all the time. So, oops, right-click here. The other one is dump, and you don't really need to. This is for, it's kind of like a log file that we need. So if we ask you to do that, then you'll know where it's at. So we did break out the machine, the coordinate, the stock, and the target. All this machine is a little bit different. This is actually a GUI for setting up posts, and you can manipulate feeds and speeds in here. As far as what your maximum spindle speed is on your machine. This particular one is 12,000. My tool change time is 8 seconds. You can change all this stuff like axes, X, Y, and Z. My axes for rapid is 1400. Feed is 833 for X, Y, and Z. So there are things that you can do in here. This would directly affect your post. Although by default, this is not active. You're not able to click in here by default. But I am going to show you one thing real quick, and you can always ask me a question about it later. If you want to be able to double-click into here, you can go to your Start menu, type in Reg Edit. Okay, so you're going to get into the registry. You're going to go to HKey Current User, Software, all the way down to SolidCAM. Even if you're using InventorCAM, that's the main directory. Then you'll have whatever you have in here. I've got SolidCAM 2013 as well as InventorCAM 2014, which is what we're working in right now. And if I click into that, there's a folder called CAM Experimental Mode. And this is the one you're looking for right here. So what you do to create that is right-click. You start a new 32-bit DWORD. Even if you're in 64-bit, you still create a 32-bit DWORD. Okay, and I'll just edit this or modify it so you can see it. Actually, sorry, you're going to rename it. Okay, Super Mock ID. It's all strewn together, capital letter of each word, and then that's it. Right-click. You can modify it or you can enter, and you just simply change the 0 to a 1. You do not have to reboot your computer, and it automatically allows you to double-click into these values here, so you can change stuff on the fly. All right. Coordinate systems, this is just a quick way of getting into coordinate systems and stock and so on and so forth. Same thing as if we'd gone into CAM part definition. Same thing as going into all these. These settings are part-specific settings. We went over the main settings last week. Notice that these settings, there's a lot more in these main settings. Okay. Once you start a CAM project, it takes some of these settings and it populates down to the part settings, which are right here. Notice there's less of them. This simply means that if you change part settings, it'll affect this model and this model only. It doesn't affect all your other CAM projects, just this particular part. Think of it as this. Part settings are just like application settings inside Inventor. You've got the other way around. You have application settings and you have document settings. This would be the application settings for SolidCAM. This would be the document settings for InventorCAM. Okay. Tools, where you manage your tools and your tool libraries. You can import, export, create tools, that kind of thing. Machining processes, again, this is for an advanced class, so we're not going to go over that. But think of it as a macro. It's a way of grouping a set of tools together to do a particular function, like the 1032 or a quarter 20 tap hole. You might use a spot drill, a tap drill, and a tap. 3 different tools, 3 different operations you can group together, and then apply it to whatever you're running into. So I generally set up a bunch of different tappings, like all the way from 632 all the way up to 1/2 inch 13. Then I can apply them to my different tap tools. Now, it doesn't just work for tap tools. You can do milling with it. You can mix and match tools. But again, that's more advanced, and we won't get into it today. Geometries folder. Remember when we talked about this CAM cleanup part? Well, as you're working, things that you're not currently using in a toolpath, a plus will be created here as soon as you create something that you're not using, and it'll just simply sit inside your geometries folder until you're ready to use those, or simply delete them. You can delete them out of this box individually if you'd like, or at the very end you can do the CAM cleanup. Fixtures, we're not going to go into it, but in order to create fixtures, all you have to do is hit define, and once you've brought them in, like your vise and table, it's just asking you to pick them. So you come out here and you select all the models that you want to see when you go into Solid Verify. Here's your faceting of those models as well. Again, no bearing on your G-code, simply how nice it looks when you go into Solid Verify. Now, the very top node, most important node on the tree. The second most important node on the tree is your operations. Most of it's grayed out because we don't have a toolpath. Now, I generally like to go into Solid Verify before we end today, so I'm going to create just a simple, let's just do a simple roughing program, and I'm going to do a standard pocket. And we're going to go in 2 weeks from now, we're going to get into these dialog boxes and exactly everything about them, so I'm not going to spend a lot of time talking about them today. So what I'm going to do is generate just a quick pocket rough on this thing. So I'm going to chain that, and I'm going to wrap it all the way around, and I'm going to mark it as open, because that allows my tool to start out here and work its way in. Then I actually want to chain this model, and I'm going to wrap that all the way around. Give it a name if you want. I'm going to go ahead and hit finish. Tools, let's see, what sizes? I think that was only, let's measure that real quick. Inspect, distance. Let's go to here. That is 1.7 or 575. Okay, no problem. I'm just going to grab a 1/2 inch tool, and we'll make sure it's long enough. All right. Levels, I'm going to pick right off my part. I'm going to start there, and I'm going to pocket it down to here. All right, and maybe we'll go a little bit further. I'll do an extra 20 thousandths. Oops, 20. All right. Now, I am going to show you one thing here. I'm going to generate that toolpath so you can see what it looks like. So it's a pocket style operation, but it's staying within that boundary. It did start outside, or actually it hasn't started out there. It's basically staying in here, but that's a soft boundary, so it's allowed to come out the edges here. But I don't want to do a pocket style. I'd prefer to do, what is my step over? I guess a pretty big part. That's why it looks that way. But now you can see basically it looks like a pocket because that's what I'm in. If I want to turn this pocket operation into a profile operation, I can go ahead into my open pocket. As long as I've marked one of my chains as open, or even one of my elements of my chain as open, this will be available to me. So I'm going to go ahead and say use profile strategy, approach from the outside, and descend in rapid to the cut level because I'm in the air. Now it's more of a profile style operation. We'll get into this more. But here's what I wanted to do. I wanted to go into Solid Verify. And is that translucent? It is translucent. Let's turn that off. Oh, I know what happened. I grabbed a 1/2-inch tool, but I didn't change my values there. There we go. That's better. And actually, I'm going to do 1.6. Okay. Now, well, actually, you're going to see this. Straight line cuts are fine. Remember that display tolerance I talked about? Any kind of rounded areas are going to be faceted based on that facet tolerance. Actually, if the part came in with rounded corners, that would be that facet tolerance that you created it with. Where the tool touches now, and actually it's looking really good, I'm not seeing any faceting right here, so maybe mine got changed, and it's possible. No, it's just a really big part. Let's do this. Let's change it to 50, so I want you to see this. Select OK. Let's go in and out of it again because it has to reset. Okay. Now you can kind of see it's not very nice. You can see faceting here and here. That's because I set it at 50 thousandths. And if you zoom up here, now that's better. You can see the faceting right here. Those are big facets. That's because my setting, my tool facet tolerance, where it touches the part, is 50 thousandths. So if we do 10, select OK. Let's go in and out again and play. Okay, a little better. Now you can see that the lines are a little bit smaller. There's more of them. But if you're trying to clear that up completely, and again, this has no bearing on your G code. It just depends on how nice you want the model to look. There we go. Now even if I zoom up on that, that's nice and smooth. Again, no bearing on your G code, just how your model looks. Now if the model had come in looking just like that, and the tool hadn't worked yet, how faceted this tolerance looks is based on that one that we talked about earlier, right inside your stock, right here, okay, and your target. So those are the two that I did want to talk about. Let's go back into there. So two things. First thing you're going to do is go to General. You're going to go ahead and hit Defaults. Okay, so that's the default. Make sure if you're an inch, it should say 4 thousandths. Defaults. Now you have Animation Redraw Interval, frames, 15 frames per second, or by a fixed step. Let's take a look and see what that looks like if we do this. That doesn't look too bad. It looks a little jerky to me. I personally like by fixed step, and I do 1. That means show every single toolpath movement. Looks about the same as 15 frames per second right now. That's going to depend on your model. Now, if you change it to something else, let's change it to 50. Now it's going to look very, very faceted. Let's pause that. Let's go in and out. Make sure that we have that set. See how jerky it is? So I personally like 1. I like it smooth, but this will slow your toolpath simulation down. Now, that's general. The other one was that accuracy that we talked about in here. You're going to want to change that. And just so you know, this compare function, the values in here can be changed. They only work down to within whatever value you have set here. So if this is set at a half a thousandths, you can set these at, a half a thousandths or below, and anything below it doesn't matter. So they have to be at least 5 thousandths or above, basically, in order for it to be affected. So, but we'll get into that later. That is all we needed to show today. Like I said, in 2 weeks, we're going to go through all the different options for selection and tools and levels and technology. We're going to go through here in detail. That'll be in 2 weeks. But today was for menus and file management only. I appreciate you guys joining me. I don't see any questions, but I will leave this open a little bit longer. As a matter of fact, I'm going to go ahead and put my name down here, my email address, darren.bryant@solidcam.com, and we'll send that to everybody. So if you have a question or would like to request this recording, go ahead and send me an email to Darren, DARRIN, .Bryant, BRYANT, @solidcam.com, and I will send you out the file or answer any questions that you have. We'll go ahead and leave this open for about another minute. We'll see if any questions come in, and then I'm going to go ahead and end the session. All right. Well, I don't really see any questions coming in, but please, if you got a question, please send it to me. Or if you have a suggestion on what you'd like to see in one of these webinars, that's great too. I'm always looking for suggestions. I appreciate you guys joining me. Please join me again in 2 weeks for, I think it's called InventorCAM Basics, Part 1, and we're going to start getting into more of the programming. Thank you for joining me, and we'll see you next time.